Greetings to this video where we're going to look at page 404. I will be working problems 14, 17, and 23, time permitting. Now number 14 starts out with a negative pi over 12, which can be rewritten as the following: 2 pi over 12 and a negative 3 pi over 12. The reason we do that is because we want the 2 twelfths and the 3 twelfths to be able to reduce into problems that we can find exact values for. And pi over 6 you recognize as a 60 degree and pi over 4 as a 45 degree. So once we have determined what we're going to use for the insides of these sum and differences, we can begin working. So what we have is sine pi over 6 minus pi over 4 gives us sine pi over 6 times cosine pi over 4 minus the cosine of the first, or pi over 6, times the sine of the second, which is pi over 4. Now we will be looking for exact values with this problem, and we should recognize that sine pi over 6 again is 30 degrees, and so what we're going to get is a value of 1/2. Cosine pi over 4, or 45, will give us the radical 2 over 2, which we're used to seeing. The cosine pi over 6 will give us the value of a radical 2, the cosine rather will give us the value of radical 3 over 2, and the sine will give us a radical 2 over 2. Now these are multiplications, so again we're going to see a radical 2 over 4, subtract a radical 6 over 4, and we'll recall that we can put these two together, radical 2 minus radical 6 all over 4. And that's a very good answer. Just be aware that sometimes we'll factor out a radical 2/4, leaving us with a 1 minus radical 3. So a couple different ways you might see this solution. Now looking at B, it does a similar process. This time we're working with cosine. And so the process for the sum and difference is the cosine of the first times the cosine of the second is, now we see a subtraction here, but according to our formula that is an addition, so we're going to add the sine of pi over 6 times the sine of pi over 4, just using our identity sheet. Now we're going to replace all of these with exact values. The cosine of pi over 6 is 3 over 2, and then times our radical 2 over 2. The sine of pi over 6 is 1/2, and the sine of pi over 4 is radical 2 over 2. Putting these together, we're going to see a radical 6 over 4 plus a radical 2 over 4. Putting the two fractions together, a radical 6 plus radical 2 all over 4, which gives us then the possibility of taking out again a square root of 2 over 4, leaving us with radical 3 plus 1. 3 plus 1 on the inside. Looking for part C, where they want us to do the tangent, we're going to then use its process, and that would be the tangent of u, or the tangent of the first, and we're going to then subtract from that the tangent of the second, and that is all over 1 minus the tangent of the first times the tangent of the second. And so we get 1 minus tan of pi over 6 times tan pi over 4. Now we're back to substitution. So our first substitution was simply putting this into our formula, and now we'll work the problem out. What that gives me for the top, I'm going to write over to the right side here, and I will have a radical 3 over 2. Sorry, over 3. Radical 3 over 3. And then I will subtract, well, the tangent of 45 degrees is a 1. That is all over my 1 plus a radical 3 over 3. Now, simplifying this out, it would probably be best to get common denominators. So a radical 3 minus a 3 all over 3 equal, or is over a 3 plus a radical 3 all over 3. The 3's will cancel, meaning that I've got a nice solution here of radical 3 minus 3 all over 3 plus radical 3. But through a rationalization technique using conjugate pairs, we will be able to simplify, reduce, and come up with the solution of negative 2 plus radical 3. Okay? Sometimes maybe skipping an intermediate step isn't the best thing to do on a video, so just realize that I am looking at these two as the same, so I'm going to get a square root 3 squared, which is 3. I'm going to get a negative 3 squared, which is 9, a positive 9. I'm going to multiply the 2 in the middle and double it, so I'm going to get a negative 6 radical 3 inside. That is all going to be over 3, a 9 minus a 3, giving me then a 12 minus 6 radical 3 all over 6. Then obviously we'll reduce that by 6 on each top and bottom. For number 17, we'll need to look at this negative 600 or negative 165 degrees is rewritten as follows. Take a negative out and look at the 165 degrees as a 120 degrees plus 45 degrees. Now, having done that, I'm going to look at A here, and I'll look at B kind of simultaneously. I substitute that in, and notice that this negative here is like a sine negative x. And that reminds me that the sine function is an odd function, therefore the sine of negative x equals negative sine x. So what I'm going to do for a start of a problem is take that negative out and rewrite it as the following. Okay? Likewise, if I look over here at my cosine, I will recall that cosine is an even function that allows me to get a positive value. So this negative here isn't going to affect it, so I could rewrite it as cosine 120 degrees plus 45 degrees. And I can do that, again, because it is a even function. So I'll simply solve these two problems and use my topics. So I have a negative sine of 120 degrees, cosine of 45 degrees. And from that, I'm going to then add a cosine of 120 degrees, sine of 45 degrees. Simplifying this yet further, I will see I end up with a radical 3 over 2 times a radical 2 over 2. And from that, I'm going to get an addition of a negative 1/2 times a radical 2 over 2. Now remember, this negative is still on the outside. Let's not forget that. So in my next process, I can see that I'll have a negative, and once again, a radical 6 over 4. We've seen that a few times. And on the right side here, a radical 2 over 2. Process of elimination will get me then down to a negative radical 6 plus a radical 2 all over 4. Let me just change this real quick. Right, the step above is supposed to be a 4. I got that. So this negative then was brought into both of these, leaving me with this answer. Now I remind you that, again, they may factor out a negative radical 2 over 4, leaving us with the value square root 3 minus 1. Our cosine, handling in the same fashion, will give us the following, that we have a cosine of 120 degrees times a cosine of 45 degrees minus a sine of 120 degrees sine of 45 degrees. Now remember that the cosine, when we're using the sum and difference, actually when we have a sum, it makes it a difference as we work the problem out. So be aware of that. Now, what values do we get? We get a negative 1/2, a square root 2 over 2. From that, we're going to subtract a square root 3 over 2 times a square root 2 over 2. So here I go again, seeing something happen that we've seen before. A radical 2 over 4, but notice it's negative. And from that, we're going to subtract a radical 6 over 4, which gives us our negative radical 2, subtract radical 6, all over 4. Well, Mr. N, I notice these problems are a lot like peas and cats. It seems like they really go together. Trig functions are these identities, I think, and you know, these formulas. They really work well. I hope your students realize that. Yes, I think they do, Forrest, and I thank you very much for your interruption, but I don't know if I'll get these all done. So we're going to look at this C, which is tangent of negative 165 degrees, and we'll make note that tangent is also, in this case, going to be an odd function. So I can write negative tangent of 120 degrees plus 45 degrees. Jumping into the sum formula, we will get the following of tangent of 120 degrees plus the tangent of 45 degrees all over 1 minus the tangent of 120 degrees times the tangent of 45 degrees. Just remember there's a negative in front of that. My next step then is to substitute, which will give me a negative out front yet, with a negative radical 3 plus 1 all over a 1 minus a negative radical 3 times a 1, which then gives me my 1 minus radical 3 over 1 plus radical 3, and I'm going to have to rationalize. Again, the rationalization will be a 1 minus radical 3 conjugate pairs, and I need to do that on top as well. The last step then will be to do a couple simplifications where I end up with a 4 minus a 2 radical 3 all over negative 2, which will reduce to a 2 minus radical 3. I will save number 21 for the next topic, and hope that you view that as well. Thank you, and hope this was helpful.